Hello, my name is Adolfo Neto, and I'm here to talk about two concepts that are important for people that want to learn functional programming. And I'm covering the basics here, so if you already know functional programming or even programming, this may be too easy for you. But let's talk about arity and types. So in the previous video, I talked about function. Let me go back and describe a function here. For instance, suppose I have a set A, which contains 1, 2, and 5, and B, which contains D and G, and we can have a function from A to B, and I can define this function as f of 1 equals to d, f of 2 equals to g, and f of 5 equals to d2. And any set can be in the place where a and b are. So, for instance, suppose now you have three sets. A is 1 and 2, B is 2 and 4, C is D and G, and from these two sets I can, as I explained in the previous video, I can have the Cartesian product of A and B, which is going to be a set of pairs like 1, 2, 1, 4, 2, 2, and 2, 4. And then I could have a function g, not g, let me use another letter, h, from this set, which is the Cartesian product, to c. So this function would have to be defined for all pairs in the Cartesian product of A and B. H, let me put this here, 2, 2. What's going on here? Okay. And H, 2, 4. Now, all I have to do is to choose. I choose D here, G here, D here, and G here. And the idea here is that this is one element of a set. This is one element, one element, one element. The element is a pair. But when we talk about functional programming, we usually say that these are two elements and that the arity of H is 2. Why? Because this means that the function H takes two parameters. In our case, the parameters, the first parameter comes from A, the second parameter comes from B. And the result, the result of applying H to one parameter from A and one parameter from B is a value from C. So that's why we can have functions with different arities. This is the plural. For instance, we can have a function like pi. Pi is a zero array function. It has zero array function, which has the same meaning as this is the arity of this function is 0. The function pi returns 3.1415.9. Let's just leave it there. So you could see pi as a function that receives no argument. you can have a function with arity 1, arity 2. So, for instance, f from a to a, where a equals 145, is a function of arity 1. F of 1 is 1, f of 45 is 1, 2. And you could have, for instance, let's keep our a here. But you could have a function g like that. G 1, 1 equals to 1 equals to 45 equals to 45, and so on. Of course, if this is a function, I would have to define it for 9 combinations of 1 and 45. And this is the part of the function. So the arity, I could say in functional programming that the arity of G is 3. So 3 is the number of elements that this function receives. So now that we talked about arity, I'm going to talk about types. And a simplified view of types is that types are sets. So I could have a type called A, which contains only the even numbers between 2 and 10, or a type called Y, which contains the even numbers between 1 and 10, and so on. Of course, for programming, types are usually more concerned with the operations, and operations are functions. So it makes sense to have a set called integers, which contain all the integer numbers. Integer numbers is actually an infinite set. Or I could have this set of real numbers, which contain 0.01, 0.9999, and so on. And the important point here, and I could have also a type called words, which contain all possible words using characters. You see, this set is infinite. All those sets are infinites. For reasons that I'm not going to explain here, but usually reals are not reals, they are floating point numbers, and words are called strings. But the point here is, why is it important to have these as types? Because there are some functions that can only be applied to integers, some other functions that are applied to reals, and every integer is a real number. And there are functions that make no sense when applied to integers, but make sense when applied to words or strings. So that's why we have even in programming languages like Elixir and Erlang, where types are not always explicit, they are there. So we have types in many. I don't know if there is a really untyped or a real, maybe yes, maybe assembler has no types, but higher level programming languages usually have types. But I'm not going, there's so many people much better than I am to talk to you about types. I only want to you I only want you to grasp the idea of types. They are special sets where some operations are expected on elements of those sets. And those operations, yes, that's another point that I think it's important, because when we say operation, we are usually saying a function. A function is an operation. It's only a special way to say, but it's in programming languages. It's usually also that, for instance, you have 2 plus 3 is 5. This is an operation, and but I could have a function plus, which given 2 and 3 returns 5. This is called a prefix notation because the name of the function is before the arguments, the elements that are going to be applied to the function, to be given to the function. And when it's infix of the function, which is plus, is between the arguments. So for us, for our context, operations and functions are the same thing, but in programming language they can be different. Okay, so that's it for today. See you in the next video. Bye bye.